title of my presentation is Signal Watch and Pay Protocol Toward a Decentralized Economy. I don't know if I can go fully... I don't think I can go fully present. See if I lose everything. No, I can't. Okay, excellent. Perfect. So, Signal Watch and Pay Protocol Toward a Decentralized Economy. Are you guys getting that full screen? Can somebody just give me a high sign if you're getting it full screen, if it looks good?
Yeah, it's looking good.
Okay, good. Excellent. Excellent. So, before I start, if anybody wants to just learn more or follow along while this is going on, here are the two URLs. The first is for the specification. The second is for a JavaScript module that works with Node.js that has end-to-end examples that are on mainnet. So that's pretty useful if you want to go through the code. It's in the examples folder. So for all of the different applications that I'm talking about here, there's basically end-to-end code where the example script will simulate all of the parties involved, and you can go down through it. It's pretty well documented, and you can go down through that. Okay, so the first thing here, what is the SWaP protocol? This is where I think that there's been a lot of misunderstanding. I believe that this is a super important protocol because it does for more advanced transactions, and we'll get into what those are, what Bitcoin did for money. So really what we're talking about here is it's a communications protocol. That's the most important part. Like SWaP is the communications protocol for negotiating and executing collaborative transactions on Bitcoin Cash. So this is about peers being able to communicate with each other. It's less about the transactions. I think a lot of people have gotten caught up on the transactions because they're kind of interesting. And there's other projects that are doing that, but the key here is really the communications protocol. But before we talk about the communications protocol, because the collaborative transactions are interesting, what is a collaborative transaction? This is a term that's been used, term that's been thrown around. What is it? Okay. Here's your standard transactions. This is at a very high level. I think that most people, even the non-technical, will be able to walk away from this because they'll get it. Here's your standard transaction. Alice pays Bob. Okay? There's three primary collaborative transactions that I find to be particularly interesting right now that I think have some cool business models behind them, and they're also being used by other projects. So this will even give you a better understanding, I hope, at the end of this, of what's going on in some of these other projects. So the first collaborative transaction that's pretty interesting and that has become very popular in Bitcoin Cash is a crowdfund transaction. So we're looking at Alice and Bob in a single transaction work together so that they can pay Carol. So that's the crowdfunding. Then you've got a SLP BCH atomic swap. So in this case, Alice and Bob pay Bob and Alice. So Alice contributes SLP, Bob contributes BCH, Bob then receives the BCH from Alice, and Alice receives the SLP from Bob. All of this takes place in one transaction. And then an escrow transaction. So this is Alice and Bob pay into some sort of an escrow address that they'll be able to receive the funds based on something in the future. This could be an oracle that's got price, that's got something about an event, this could be a time lock. There's tons of different things that this could be. It's some sort of an escrow contract that has some arrangement within it, and in one transaction, they're both going to pay in and fund it. So let's talk about collaborative transactions in the wild. So crowdfunding is Alice and Bob pay Carol. The thing that everybody's been using lately and that uses this basic model is Flipstarter. And so SWaP helps you to be able to do Flipstarter. SWaP isn't Flipstarter, but it helps you to be able to do the same type of contract that Flipstarter helps you to be able to do. You have your SLP BCH atomic swap. This is basically an exchange on-chain in a single transaction. Alice and Bob pay Bob and Alice. So what's using that in the wild? Well, the SLP postage protocol is basically that. You send some SLP up to the post office, and in exchange for that, the post office is going to collaborate inside your transaction by adding on some BCH. So you basically are buying some BCH with your SLP, and then it's putting the BCH into the transaction collaborating with you. Side SideShift AI is also using a version of this. So if you do BCH exchanges for any of the SLP tokens that they offer, Spice, USDH, now USDT, Tether, they will actually do this. So you'll notice if you go and you do a SideShift AI shift of BCH for one of those, it happens very, very quickly. Because they're basically doing almost the equivalent. They're doing it it's a little bit chained. They haven't fully done collaborative, but they're using it like in a chain of transactions. So it's almost as effective there. And then escrow with the Oracle. So that's Alice and Bob pay an escrow contract. And people are very excited about any hedge. This is what I've been working on the most in, let's say, the last year. If you go to my JavaScript module, Jeton-lib, which is basically an extension of bitcore-lib.cache or bitcore-cache.lib, I always get those confused. But it's the Bitcore Bitcoin Cache libraries. You'll be able to use 3 different types of escrow contracts there, and there's some full examples also in that. The three types of escrow contracts are escrow with like an oracle. There's escrow with a price oracle, so an event oracle, a price oracle, and then the latest one that I added was actually a covenant. So like a pro rata covenant, where you could say, okay, this can be spent by anyone, but it has to pay 50% to this address and 50% to this address. So it's a cool way of doing things like fee addresses. If you wanted to set something up where there was a permanent fee address, and no matter who paid, that it would always go, let's say, 30% to each of the partners and 10% in a business and 10% to, I don't know, some general fund that you guys are using, you could set something up like that, only using one address and knowing for sure that it would be trustless. So that's very good. It gives you, the cool thing about collaborative transactions, one of the most important things, I mean, as you look at these applications, the most important thing, I think, is that it's trustless. In each of these cases, if somebody collaborates with you on a transaction and then they double spend the transaction, no harm, no foul. Basically, they can't take your money. So them getting what they want, especially in the case of the SLP BCH atomic swap, them getting their money is dependent upon you getting your money. Can't get better than that. You can't get better incentives than that. That by screwing themselves, they'll screw you. So there's basically zero incentive to double spend. It gets them nothing in this case. So it's quite good. It's quite good in that regard. The other thing that's interesting with the crowdfund, and Flipstarter uses this, is that the nature of the BCH transaction, where the total input amount has to be more than the total output amount. That total output amount plus whatever minor fees are necessary. That automatically gives you an assurance contract. That's basically the same thing as all the various different Kickstarter, right? To where it's like, if you don't have all of the funds, and we're kind of seeing that on some of these flip starters that aren't getting the full amount of funds, where people are like, oh no, we need to have an option that says, no, let it be even if it's not fully funded. Well, that doesn't lend in the incentive. It's a good incentive structure to have this assurance contract. It's known. It's a known in economics. It's a known way to sort of mitigate the free rider problem. So it's like you donate, and it's sort of a way of finding consensus that if the rest of everybody, or maybe you think it's a great idea, but you're only willing to put in $20, but it needs 1,000. And if the rest of the people around are like, man, that's not even worth a penny, then you actually get the knowledge, the price knowledge of the market, while still being able to participate up front, and then you are able to get your money back. So it's a really cool mechanism, and it just so happens that the Bitcoin transaction structure allows us to do that, like, out of the box. So as you look at these things, like, crowdfunding is something that can be done on all of the Bitcoin chains. This is something that model of everybody contribute is something that can be done on BTC too. The SLP BCH atomic swap, technically that can also be done on BSV. I just don't think anybody is using the SLP BSV at this point, but they certainly could. I think a lot of people haven't realized that, like, it can be used on any chain that has a sufficient op return of a sufficient size, and BSV certainly does. So I think there's probably a pretty good chance that somewhere down the line, somebody on BSV is smart enough to realize this. They're going to rename the token, of course. They're going to rename the protocol and just fork it off. But they will probably have them as well, and they'll be able to do these atomic swaps once they figure it out. But the escrow with the Oracle, because of OpCheck DataSig, that can only be done on Bitcoin Cash at the moment. So again, I think it's one of the reasons why that's the most interesting and futuristic and something that I think people should be focusing and spending their time on. Okay, so those transactions are possible, no problem. No problems. So now we get into what does SWaP solve? So it's not a matter of the transaction, but it's a matter of answering these two questions. And they're a problem of coordination. And at the end of the day, Bitcoin is a coordination engine. That's what it's for. That's what the entire idea of Nakamoto consensus is. It's about how can people who have no knowledge of one another coordinate in a trustless way a global financial system. It's a big problem. Satoshi Nakamoto solved something that is like a philosophical problem. Very interesting. It's a big problem. So here's the problem of coordination. We know that we can make these transactions. We know that two people can participate in these transactions together, or three, or four, or five, or 100 in the case of like a flip starter. But you've got two questions. One, how do I know, sitting here in Saipan, that Chris Troutner over there, halfway on the other side of the world, wants to sell some permissionless software foundation tokens right now and is willing to accept Bitcoin Cash? How do I know that? If I don't know Chris, and I know Chris Troutner, he could probably reach out to me and say something, right? But let's say that I don't. Let's say it's my neighbor over here. How on earth would he know that? And then the second thing is, how can we collaborate in a trustless and censorship-resistant manner? So even if I do have some access to some way that Chris and I can communicate and say, hey, let's make this trade, if we're going through a middleman who can censor that because he doesn't want us to make a trade or he doesn't want us to know that each other exists, well, the point of Bitcoin is kind of destroyed. So what we can do is we can use Bitcoin to answer these two questions. One, how can I know that anyone in the world wants to participate with me? And two, how can, when we're negotiating the contract, we communicate in a trustless and censorship-resistant manner? So let's talk about how it's being handled now in the wild, and you'll get an idea of, I think, while the solutions that are right now are good, why I have seen that there's a problem there, right? So let's take a look at Flipstarter. This is the first kind of collaborative transaction. This is our crowdfunding transaction. So what can you do? You want to start a Flipstarter. You want somebody to contribute to your Flipstarter, right? You need some funds. You want somebody to contribute. Here are your options, pretty much. It looks like to me. One, and this is what people are doing. You can announce your campaign on a social media platform. So you go on RBTC, you go on Twitter, you go into Telegram groups, and you say, here's my Flipstarter, please contribute. Now you can see how that's not really great at scale, and how you're also potentially missing a whole lot of people. Because you're limited by whoever's on the platform. So for instance, I'm never on Discord. If you decide you're going to come on and promote on Discord, well, I know nothing about it. I know nothing about that, right? Your other option is you can create a listing platform. So you could create, people have asked, well, where can I go to see all the Flipstarters, right? Is there a place where they're all aggregated? Well, okay, that's fine. But what if I don't know that URL? What if I'm just not aware of it? So you're relying upon these platforms. So again, we've got platforms. So Postage Protocol, right? This is a protocol that I developed. It suffers from the same problem. Now, it's not necessary. I think Postage Protocol nature of it, maybe it's okay, but you still run into the same problem of coordination, right? So what are you stuck with? Well, you want to know where the people ask this from the beginning. Well, how do I know where all the post offices are that are competing? Well, what if you want some competing post offices, right? So what have I been doing? Well, I hard code the post office API server information into the application, the URL or whatever. Maybe I put in a list, maybe I put in just one. That's fine, but it's still limited. Or what? I could create a post office listing platform, perhaps, and I could pull from a lot of different places, and then you could use maybe that API, but still, we're still in a case where there may be somebody here in Saipan who's got a better deal for you, who would love to do business with you, who would love to make that exchange, but you don't even know that they exist. And they don't know that you exist, and there's no protocol for the two of you to be able to talk to each other. And then the third one is any hedge. So this is when we're talking about a custodian, Alice and Bob pay to an escrow contract with an oracle. This is actually a really hard one because you have three parties. One of them has to be blind, should be, the oracle, should be blind to what's going on in these other contracts. We don't want to put that risk in there of them actually participating and sort of, putting out the wrong signature and screwing things up. So you need a level of trustlessness, so you need that blindness. It's a very difficult problem. This is something that even back in the first time I had a conversation with the General Protocols guys, as individuals, was back in Australia, where I told them I was working on this problem as well, which I have been primarily around sports wagering and prediction markets. And I realized this is a really hard problem. And so, I had conversations early on with them about well, how are you guys handling this? Because I, at that point, couldn't figure out what to do. And they so far, sort of the most viable solution, the one that makes the most sense, is you go to an exchange. The exchange has all of the people there. They're able to coordinate and communicate with each other programmatically in the background, and you do it on an exchange platform. So that's fine, but I think that we can understand that if you're using a custodial exchange, you're already in the censorship, the non-censorship resistant model. If it's something I had to sign up for, they can cut my account off at any time. Once you're on the chain, you're pretty good. But again, you're also limited by who's on the exchange, who's on the platform. You don't get to potentially leverage every single person that's on the Bitcoin Cash network. So, Signal Watch and Pay protocol. The problem that it's solving here and what it does is, one, it's totally decentralized. It's as decentralized as the Bitcoin Cash network because everything that happens is riding on Bitcoin Cash transactions. So in the same way, it's censorship resistant. In order to turn off SWaP protocol, in order to censor somebody, you'd have to be able to censor a Bitcoin Cash transaction. So that in and of itself, if we believe that Bitcoin Cash transactions for our money are censorship resistant, since these are all Bitcoin Cash transactions through which the communication is happening, we get that censorship resistance. It's universally available. Anybody that, anywhere that the Bitcoin Cash network can reach, SWaP protocol, every single person that's within reach of that can participate with every other person. And I think the most important part, it uses existing Bitcoin Cash infrastructure. So if you've got a wallet currently, if you've got a wallet that can do SLP tokens at this point, because it's reading op return and this uses op return, you can code into that wallet without adding it besides the Signal Watch and Pay protocol. If you want to use the library that I've written, you could write that in and make it easier. But even if you didn't have that, you could write it in right now based on spec. So it's just another way of reading op return and another way of sending up transactions. This part was very, very important to me. It was important to me that we could do this with what we had on Bitcoin Cash. And then that would mean that there necessarily, if this is valuable, will be much competition among people to write the various libraries in many different languages. And it's sort of open source out the box. If you've got the spec, you can build this thing. And it's really not all that difficult to build, to be honest, once you understand the spec. So let's talk about what's happening. It's called Signal, Watch, and she's going to broadcast up onto Bitcoin Cash. Now, this is very similar to some people who have used like memo.cash and the memo protocol, that you're broadcasting a message up, and anybody who can read the memo protocol, it's just a protocol. You broadcast it with the memo protocol. Anybody who can read it, it doesn't have to be on memo.cash. Anybody can pull it down. This is similar in that way, in that it's specially formatted. It has some tags to say what it is. It has the information to say how much BCH she wants to trade. As a matter of fact, she's actually telling you what UTXO specifically she wants to trade. So she's saying, this UTXO right here, I want to exchange this for Spice. I want to exchange it at this exchange rate. So she broadcasts that up to the Bitcoin Cash network. Now it's there. Now anybody can see it if they're watching. So you've got Bob. Bob is watching the Bitcoin Cash blockchain. He's got Spice. He's watching for someone to say that. His wallet is watching. All of a sudden, boom, someone wants to make an exchange. Now you'll notice that this model starts to look like an exchange order book. So when we're talking about doing this exchange, what we've basically done is eliminated even the need when you're doing a BCH to SLP exchange for an exchange period. We have the capability to have a global order book. No exchanges. It's just right there in your wallet. You say, I want it, and it's saying, these are all the people willing to sell. It becomes this bazaar that you're able to walk into and see everybody selling their wares and competing at different prices, right? That's what it looks like at its most evolved level. So Bob is watching. Bob's got some Spice. Bob now sends another signal up, and he basically directs it right back at Alice. And he says, listen, this isn't what the signal says, but this is what it communicates. I want to exchange my Spice for your BCH, and most importantly, I've already created the transaction. I've already created the whole transaction. It's just missing your signature. I've signed it. It's here. It's a valid transaction. Here's what it looks like. All it needs is your signature. And he broadcasts that back to the Bitcoin Cash network. One of the things that you notice here is neither one of them knows where the other one is, who the other one is. High level of privacy here. High level of privacy. Alice is, of course, watching. She sent out the signal, and watch. She sent out the signal. Now she's watching to see if anybody responds to her signal. Bob has responded to her signal. So she gets this half-signed transaction. She takes a look at it, says, okay, that's good. She signs her part. Now it's a valid transaction. And she broadcasts the fully signed transaction up onto the Bitcoin Cash network, and we're done. And we're done. Alice has gotten her Spice, or back for her BCH. Bob, I know, I'm getting a little confused here. Bob has received BCH in exchange for his Spice. They've done it all in one transaction, and done. Trustless, decentralized, globally available, and using all of the existing infrastructure that's already in your wallets right now. So I often say, what's the canonical application? I know I probably bug Chris Troutner with this all the time. What's the canonical application? Well, what does canonical application mean? Canonical application is like, well, it's not even the killer app. It's like, what is the thing that this will be most used for? So for instance, you can use a car for a lot of things, right? You can like fill a car with all kinds of speakers, and then you can take it out and it can be a sound system if you want. It could be a generator if you run out of power. You know, you could turn it on and it could be a generator of electricity. But what's the canonical application of a car? Well, it's a mode of transportation to get you from point A to point B. That's it, right? That's the canonical application. So what are the canonical applications? Now that you see sort of how this communication works, extrapolate it out into this universally available, decentralized situation. What are the canonical applications of just these three? And that's to say this can be expanded out because it's just communication, so it can easily be expanded out, and the spec allows for expansion. As we get other capabilities, of course there will be more. So with the crowdfunding, what are we talking about? What are we talking about disrupting here? What industry? Equity investing, right? So while you can do things like Flipstarter, you could also do things that are more like securities. So that we're more like, I want to fund an actual exchange for that funding, for instance, let's say you get SLP tokens, right? And those act sort of like shares that you could pay back out to. I do believe that this is going to happen. I also have sat down and worked with a few people after I released SWaP, and hopefully in the next year I can write more about this. But it does look like there may be a way to do this such that it is actually exempt from like SEC security regulations if it's done correctly, and I think that could be highly disruptive. Of course, assurance contracts, that's already being done with Flipstarter, but you could have a situation if you took Flipstarter plus the SWaP protocol and just added it in as a protocol into a wallet, you could have a situation where your wallet could actually be dinging you if there were new Flipstarter campaigns that were coming in, and then taking you to let's say an IPFS link that had information about what was going on with that you could look into, and then you could just fund it. You wouldn't need to be, you could just turn your notifications on in your wallet, and it could ding you. And it would do it all through the Bitcoin Cash blockchain. SLP, BCH, Atomic Swap. Okay, well, what are we talking about here in terms of canonical applications? Truly decentralized exchanges. And I mean truly, like we're talking peer-to-peer, where it's just like me, you, and the Bitcoin Cash blockchain. Nothing in between. No one in between. Peg stablecoins. This is something that's actually, that I haven't talked a lot about. I think that this is incredibly powerful. This is actually written into the spec as a piece of it, expecting that this would be there. But if you have a situation where I can see your holdings and you can cryptographically prove to me your holdings and the UTXOs that you're going to use to exchange with me, you actually have a situation where you can do a peg. So this is how like the central banks do pegging, like the Bank of China pegs to the US dollar. It's based on reserves. So this would be the first time that we could have truly decentralized peg stablecoins. So for instance, you could peg to BCH to where depending upon the price of BCH, one of these tokens would always return you back $1 worth of BCH. So that's something that could be done all on chain. Very, very interesting, the ability to give ourselves a stable coin that was based completely on BCH. And then escrow with an oracle. I mean, these are pretty obvious. These are pretty straightforward. Prediction markets of all different kinds. Sports wagering, that's a type of a prediction market. It's $150 billion a year global business right there, right? So this is possible to disrupt that. It also turns out when you do this with sports wagering that it's regulatorily exempt, especially in the U.S., which is important. And futures, futures, this is something that any hedge is doing, but it could be done with any sorts of futures markets because those are prediction markets. So, again, if you want to learn more, these are the URLs. I'm going to do some island hopping a little later on today, so I can do about, people have questions, I can do, about 15 minutes, I think, of questions. I'm looking in Discord as well. I don't know which one of these places there's questions, but if anybody has questions, that's it for me.
Yeah, I got a question, Vin. So the implementation right now for the watch part, I think we've talked that it's BitDB, but I like this. I like the idea of that it's more of a memo thing, and maybe the wallet can do it on its own. Can you expand on the options there? Like, is BitDB the only practical way of doing this that you've found so far? Are there other implementations that you've been thinking of?
Well, right now BitDB is sort of the best because of the indexing. So this does require that to do this well, it requires the type of indexing that BitDB does, which allows you to search for pieces of the op return. It does that really interestingly. So it allows you to really separate out data within an op return, and then BitDB indexes all of it. So in this way you can kind of search, and that's the way that the op return in the protocol is laid out. You can do a search, for instance, that says, show me all of the available offers to participate in an escrow contract that's using this particular oracle, and that is taking this particular side of the bet, right? So you're like, I want to take the long position. He's taking the short position in a futures contract. I want to take the long, and I want from this particular oracle. And then it can show you all of those that have been done. So it does require a level of indexing. I'm hoping, I mean, BitDB is available, but I think that with the work that it seems has been started with James Kramer and JT Freeman on the BCHD node with the SLP indexing, it seems like the next logical step with that would be more advanced, at least an option for more advanced operaturn indexing. And then in that case, you could just directly point at a BCHD node. But capability-wise, if you wanted to devote the resources on your own device or on your own application, this certainly could be done in an SPV wallet, right? So as the SPV wallet is seeing, transactions come in, it can be looking for those. That is certainly a capability. It's something that could happen. I think, it's probably for the moment we're going to be calling out to infrastructure with the wallets, as we are in the case with most SLP tokens. But certainly down the line, there's nothing to say that you couldn't take this in, and then parse it as it was coming in. And then even, the cool thing about it is that you can tell, because of the way that the protocol works, you can tell which signals let's say, have already been paid, which signals are no longer available, and whatnot. So you could literally prune those out of your database. They're just not important anymore. So it does give you some opportunity for garbage collection in that way. That's the future, and I hope that as this is more valuable, that people will be inspired to find new ways to do this. I'd love to see it happen all within a single wallet. I just, at this point, we're not quite there, but it's totally possible.
Yeah, just food for thought. I was actually just talking to JT about this yesterday, and he had the idea of if you could add webhooks to a full node like BCHD, so that when it encounters an op return that has a specific locat ID, it can fire a webhook, and you could just load that in when you start the node with a CSV file. So that was kind of the idea we were kicking around. I think it would fit well with this.
Well, I mean, if you can get the cool part about this is that you don't really need any more information in this except what's in the op return. Mm-hmm. So very different than an SLP token. There is no external information needed. All the information that you need to do what it is that you're going to do is included within the op return. The sort of exception to this might be if you for the crowdfunding, if you wanted to put some additional, there's a field for an additional a URI in there if you wanted information about the crowdfund. But in the case of the contract, and in the case of the escrow contract with an oracle, and the case of the exchange, the atomic swap, everything you need is within the op return, or within another op return, so an oracle op return that you would need to call out for. So yeah, I mean, I think that the idea of a webhook is interesting, but it's, in this case, it adds another layer. This is a very, very simplified and I would say efficient protocol in terms of making those communications. Mm-hmm.
So, Vin, hey.
Hey.
I've got a kind of complex problem here, and I'm looking like this is probably the answer. I just have a couple questions about it, right?